BlueOS runs on the vehicle's onboard computer and provides the basic features and tools to build the features that users want. Rusty will explain the motivations behind BlueOS, give a live demo, and share the future roadmap. So with that, I hand it over to Rusty.
Yeah, cool. Thank you very much, Doug. Thanks for setting the bar low from my presentation quality. That's nice. So thank you all for being here. I guess this is a forum, so I want it to be a forum like, I'm gonna talk about a topic that something I've been working on and just share it. I think it's cool. I'm sure it's not relevant to everybody here, but maybe it's relevant to something. But I'm like happy to steer off in other directions or answer other questions as well. But I'll start off with that and then we can kind of just see where this goes. All right, first off, this is me taking advantage of Google Meet's new camera in the presentation feature. So I'm the founder and CEO of Blue Robotics. And I'm gonna tell you a little bit, I'm gonna tell you our like starting story and how we got to where we are today. Can you raise your hand if you know what Blue Robotics is already? Just so oh, cool, wow, nice. Okay, well, cool. We're turning 10 years old this year, which is pretty crazy to me. Still feels like we just started, but started 10 years ago from this idea right here. I learned to surf a couple of years before. I had an old broken surfboard and I was bored with my day job and decided with a friend that we were going to, why not, we said, why not make a solar powered surfboard and send it from Los Angeles to Hawaii. You know, take like a couple of months under solar power, keep the budget as low as possible. We just thought it was super cool. We were really inspired by the wave glider, but like turned off by the price tag and thought we could do something, you know, way cheaper. So played around with that idea. And you know, it's if you think about this, it should be pretty easy. Like it's easy to get a GPS, you know, easy to get, just gonna use an Arduino microcontroller. Satellite radio, it's a couple $100, solar panels bought on eBay, compass, basically all you, compass and GPS is all you really need to steer, temperature sensor, so it's collecting something useful, and then 2 thrusters to propel it under solar power. And so started working on this, thought we could do this in like $1,000 to $2,000 budget, you know, broken surfboard, just some spare parts. And then, but got to the 2 thrusters to propel it, and there were like no options on the market at all. There's a company in San Diego called Technodine. There are thrusters that make like 5 pounds of thruster, $3,000 each. We needed 2 of them. There's Robotics in San Diego also. They were like $1,000 each with an educational discount. There's high school and college ROV competitions that students compete in, and they were taking like bilge pump motors from West Marine and making the impeller off and gluing the propeller on there, and like, that's $20. So like that was the market at the time. $3,000 military grade product or $20 hacked together product, and like nothing in the middle. And thrusters are like core, they're like a core part of marine robotics. Almost every vehicle is going to need thrusters. So like my mind was kind of blown. I was working in the aerial drone space at the time, so I was like, if you guys are familiar with that, like you can buy anything you want. You go online, there's stores where you can buy propellers and brushless motors and airframes and landing gear, and like this stuff is just all over the place. It's all very, very cheap. So stumbling into the marine market and realizing that this stuff is crazy expensive right now was pretty eye-opening. I couldn't believe it at first, kept looking around, couldn't find anything better. So we kind of pivoted to addressing that problem. Before that, we did actually build the Solar Surfer. Has some 3D printed prototype thrusters on there. I did not make it to Hawaii. Send it on a couple trips. It had this big keel on the bottom here, and that's like filled with lead weight. It's like a guy that welded at a brake shop, and thought that would flip it over if it flipped upside down. But that didn't work, and it was really great at snagging kelp. So every time I sent it out, it ended up getting caught in a big pack of kelp and did not have the power to things forward. So that was 10 years ago. Our mission in that time has become to enable the future of marine robotics by solving that problem. First with thrusters, there's one of our P200 thrusters here. This was our first product. You're welcome to pass that around. But once we had thrusters, we realized there's like so much room in this space to enable people. So like thrusters were first, but then once you have a thruster, then you need enclosures to put the electronics in for the batteries. You need connectors, you need lights, you need cables, you need electronics, you need software. And eventually we had all the components to produce a whole vehicle. So in 2016, the thruster launched through Kickstarter. In 2014, the ROV launched in 2016. And then most recently, and the ROV is right there, you can see the most recent version of it. And then in the back, we have our newest product, which is called the BlueOS. It's a 1.2 meter long unmanned surface vessel. So there's a couple of them here, but we have 350 products in our store, and our goal is to be like, when you have a crazy idea, Rocket just sounded like you had a crazy idea, you should go to Robotics and buy the parts you need to make the prototype. Figure it out. That's our goal. That thing going pretty well. We built like a large community around that. Some of the pieces on here are ours, some of them are adjacent. Like we love supporting the ROV and AUV competitions like RoboSub and RoboVote. The main ROV competition, those are the future of this industry. That's where people are going to get inspired. We contribute to open source projects like RGSub. The three on the top there are kind of all brands of ours. BlueOS is what I'm going to talk about today. We've been doing these, just last year we held our own like mini trade show / open house called Blue Tide. And then at AGU in New Orleans held a happy hour after the event there. So we kind of built up this cool network of things. And then this is just a peek at kind of the people here during COVID. We're based in Torrance, the Los Angeles area. We were originally all there. We've got about 60 people now, and during COVID, we leaned into the remote thing, so now people are scattered all over the globe. The yellow dots are our distributors. We've got about 55 of them around the world. And then each of these boxes is a team or a person. Main headquarters here. We've got a satellite office doing research and development in Victoria, Canada. We've got a couple people up in the Bay Area, one person in Hawaii. We've got our whole software team almost, and the people who worked on this BlueOS software I'm talking about today all live in Florianopolis, Brazil. Pretty cool place. And then I've got a few more here, one in Australia. He's always sleeping when we're awake and vice versa. Yeah. And then last slide on us. So I think this just summarizes who we are as a company. The goal is to enable the future of marine robotics. In doing that, we believe in using open source software, contributing to open source software, helping with education, supporting ROV competitions, inspiring the next generation, sharing knowledge, put lots of free resources on our website, lots of tools, lots of calculators and things like that, and building a community. We've got an online forum, like Discord community for BlueOS. Try to do events like this where we can have conversations and meet a bunch of cool people. I think things we do well, hopefully, are innovative designs, making things low cost. In the last couple of years, we've gotten really good at quality. We weren't originally, like we started in my garage, put the first 600 thrusters together like on a Costco folding table in my garage, know nothing about manufacturing. But now we've got a whole manufacturing engineering team doing things very legitimately, and everything's coming like pretty awesome. Pretty proud of that. We're good at affordability, and we're good at shipping speed. We've got all these components are in stock in our store. If you order one today, they'll probably get here tomorrow. And then things we don't like explicitly don't put a lot of focus into are we don't pursue a lot of government contracts. We're not doing military stuff. There's like enough other cool stuff going on that we don't have to do, and we get a really big, diverse worldwide community without having to pursue that. And the historical market for subsea robotics is often oil and gas. So, we're trying to open up new markets, stay away from that, and still figuring out feelings on deep sea mining. But we definitely sell to all of these groups and support it through distributors, through OEMs that are using some of our components. Yeah, any questions so far? Cool, sounds good. Let me show, I'm just gonna point out these products. So we've got the T200 thruster right here. And then from Reach, this is one of our watertight enclosures. This is like one of the smallest ones. We've got these up to 8-inch diameter. This one here would be like $300. They go to like $1,000. We've got some cable penetrators. These are like compression cable gland seals rated to 950 meters. These modular end caps, so you can basically build a custom enclosure on our website, get it delivered right away, pass that around.
What's the depth rating on that?
Most of the aluminum ones are 950 meters.
Who makes the compression fittings?
We do.
You do, okay, nice.
Yeah, that's one of the products I'm most proud of.
Yeah.
They're awesome.
Those are designed for a specific cable.
They're designed, we have them for cables from 3.7 millimeters to 9.5 millimeter diameter. So basically any cable that fits in that range. We've got our T500 thruster, which is a bigger version of the T200 here. The Blue ROV2 back here. This one is set up in what we call the heavy configuration with 4 thrusters on top here, so it has 6 degrees of freedom control. There's lots of examples of our other components on here, like penetrators on the back. There's pressure sensors, lights, gripper in the front here. We also sell some other companies' products. We've got a Waterlink DVL on this one, our Ping Echo Sounder down here. I guess like price wise, so the T200 is $200, T500 is about $700. This runs about $5,000 to $7,000, depending on how you configure it. And then last, the BlueOS back here, our newest product is about $4,500. And it's meant to be a pickup truck for whatever you want to do with it. Put a water sampler on it, put solar panels on it, but whatever sort of equipment you want to be carried in. And trying to make that more accessible. Surface vessels are a place where it's been expensive for a long time. You easily spend more on a surface vessel that size in your car, which seems kind of crazy. Yeah. So today I want to talk about BlueOS. Before I get there, so I want to talk about BlueOS, which is a software project. Everything else here is hardware. Most of what we've done historically is hardware. But BlueOS is a software project. So this is actually new to me to be sharing about software. It's way harder to explain to people who can't handle something. And we've been this is born out of necessity for us, but we think it could be useful to lots of other people. And we want to figure out how to share it as much as possible and get contributions back and make it a really, really cool thing. So BlueOS is a platform for robotic vehicles. It's got a focus on usability, versatility, robustness, and development. And it's supposed to be a very collaborative ecosystem, a place for not just us to share software, but for other people to write software and bring it back. And probably most importantly, and most differentiatingly, is that it's completely free and open source, so anybody can go and use it. And so I'm gonna mix in some demo here today. I've got this Raspberry Pi computer with a Navigator autopilot shield on it. I can pass one of those around as well. The Navigator on here is one of our products. It's a flight controller that works with the Raspberry Pi computer. So I'm gonna be doing my demo with this sitting here. This is running BlueOS on it right now. So I'll just jump out here real fast. And this is right here. This is the BlueOS instance. You can see the web address here is blueos.local. This is the BlueOS instance running on this Raspberry Pi. And this is its interface served up through a web browser. I'm just in Chrome here. And won't go into details right now, but you can see there's a bunch of stuff on the left. Bunch of features here, some typical operating system type icons at the top left. And getting to this is taking the SD card from this, flashing it for download a file, flash it for 2 minutes on my computer, plug it into the Raspberry Pi, boot it up, and I'm here. Very, very easy startup process. It all makes sense as I keep going. The GIF over here is just showing some of the features. I'll show you those live in a second. And then it's also showing this here is the extension store, which is probably the coolest part. I'll get to that as well. So BlueOS is designed to be simple by default, and user-friendly, but very powerful and flexible when needed. So who is it for? Is anybody building a robotic system? Raise your hands if you're building a robotic system. Nice. Okay, cool. So half the people in this room. And definitely targeted towards researchers, students, competition teams, vehicle manufacturers, sensor designers, software developers, and robotics users. Not actually just for ROVs, but we'd like this to apply to drones and ground vehicles. And as you see more, maybe you can imagine other applications where you could use this system. Start on the left here. So the big things that BlueOS is it gives you a starting point. If you played with a Raspberry Pi before, you put a Linux operating system on it, and then from there it's a little hard getting started. It's a steep learning curve. It's hard getting to a graphical user interface. You got to learn some command line things, and then to manage what's going on there. If you want to stream a video from that or run some other processes, like you end up with these kludged together scripts, and it ends up not being sustainable, not updatable. This is what happened to us. Our ROV originally had like some, bunch of scripts on the Raspberry Pi that started up when it booted, turned on the video stream, turned on the communication. But if we wanted to make an update to that, it was very difficult. When people had problems, it was very difficult. And when people wanted to add something to that, they said, I want to add a dissolved oxygen sensor to my ROV and talk to it. It's very, very difficult to do that in a friendly way. So we're trying to solve that. It's very importantly maintainable and updatable, meaning like I can click a button and update to the newest version of BlueOS if one came out today. The extensions that are in there can do the same thing. I can roll back. It's very robust in that way. And then you can share these extensions, and extensions give you additional features, support for a dissolved oxygen sensor or some extra payload or a rock drill or whatever you have on your vehicle. So basically today I'm going to share the vision for this, kind of walk you through it, trying to figure out how to explain this to people. So if anything doesn't make sense, just let me know. I'm learning how to explain this product. And hopefully some of you will end up being users or collaborators or contributors or inspired by it in some way. And note, it's very much still a product in progress. So if something goes wrong during the demo, that's just me. Okay, any questions so far? All right, cool. So I'm gonna give you like a high level overview just of how things are stacked up. This isn't terribly important to know as a user, but it's helpful to understand. So you've got physical vehicle. This is running on the ROV and the boat for us, but on other people's vehicles as well. You probably, not necessarily, but you probably have a flight controller like our navigator here or a Pixar autopilot. You guys might be familiar with that if you've done any drone work before. And then you got Linux operating system, and that's where most people would start with a single board computer like a Raspberry Pi. They'd start with just Linux on there, and then they'd have to build everything on top of that. And so with BlueOS, it gives you an extra couple layers on top of that. The first part is BlueOS itself. We call that BlueOS core, and that's running in a Docker container. Let me explain that real fast because it's really important. Docker, containerized architecture and software is like, I have an analogy to, I guess, can you raise your hand if you're familiar with that concept? Containerized? Okay. For those of you who aren't, the analogy to explain this is it's like if you like to cook, if you make your favorite cake at home with your own pots and pans and whisks and oven and everything, it's like very easy to make the cake just the way you want. But then you go over to your friend's house and you try to make that same cake. And you have to use their pots and pans, slightly different size, their oven runs a different temperature, and like it ends up turning out so. And so that often happens with software. Like you run some software on one Linux and then you move it over to a different computer that's also running Linux, has the same things, but like doesn't quite work. And so a containerized architecture and software is like having a food truck. So you make it on the food truck at home, and then you drive over to your friend's house, you make it on the food truck again. All the same tools are there, all the same in software speak, all the same like libraries and dependencies and permissions and everything are all there and containerized in this food truck, so that as you move around, nothing actually changes. And you can imagine then you've got a whole food court of food trucks, all doing their thing, all operating in the kitchen, all turning out great food. One of them can drive away, a new one can drive in, and it doesn't mess anybody up. So the whole system is built like that, starting with the core container, but then all of the extensions on top of that are also built into containers. It's the same thing that happens on your phone, actually. So like if an app on your iPhone crashes, it doesn't take down the whole thing. It doesn't rely on another app being there for one app to work. They're all containers. Okay, then on top of that, we've got some core services. I'll show you those. A web user interface, bunch of APIs, or application programming interfaces to talk to all those services and get data. And then on top of that, we've got extensions, which is the cool part. That's where you can add your own capabilities, build your own features for your vehicle. So even like if your vehicle is very different than the ROV, it's totally fine. We have a thruster test tank at the office it'll run thrusters and it needs an electronics update. And I'm thinking about just using a Raspberry Pi with BlueOS because it gives me a user interface right off the bat. And I've got some tools to start up, measuring a force sensor and commanding a thruster very, very quickly. We cut down the time to set it up immensely.
Which
Yeah.
version of Linux are you running?
Running Debian Linux, I have no idea what the version is, if that's a church.
Sure. Thanks.
So, any questions? I'm gonna show you some of the like core features in there. Any questions? All right. There's a Pi remote I'm gonna turn on so that you can see everything. So let's go through some of them quickly, alphabetically. We've got a service that runs an autopilot. So this is running the RD-Pilot autopilot code. You can also run PX4 autopilot code for any different vehicle type, a drone or a sub or a ground vehicle or post. And it's just running it within Linux. So you can update the firmware, restart the autopilot, etc. You can, like, there's a service to access parameters for that autopilot. There's a list of available services, just going alphabetically. This does not make total sense, but all of these have API documentation and have an endpoint so that any of these can be accessed by your own service as well. There's like the autopilot in here. There's NavLink, which is sending all the messages between drone components. There's the version chooser. This is where like I could click if I wanted to see what our software engineers were built 20 hours ago. I could click download and apply, and in 2 minutes we'd be running the newest version. And I could roll back to an old version, which is super nice. That wouldn't mess up any code that you've written on there. It's all kept separate. Skip those 2 sections. There's like a network test capability in here. So if you have a radio or a tether, you can figure out how fast your internet connection is and how fast data is going through there. It's got a system information page. Lots of these things are what you'd expect in any operating system, like what your CPU temperature is, what your disk usage is, what processes are running. It's got a terminal in here so that rather than SSHing to the Raspberry Pi, you can just click that and it's immediately start working at a lower level. For us, we've got a vehicle setup page where you can see all the things that are configured for your vehicle. You can see a view of it. If you change things, it'll change live on the vehicle. Got video streams set up. I don't have a camera connected to this one, so there's no video streams. And then the rest of the cool ones are extensions, and so let's jump to that. So those are 4 features. And then there's, okay, let me do this slide. Okay, so we just talked about the core features, just the basic stuff you need, the things you need. And then slide says, and then it has the tools to build what you want. So we have this extension system that can run other containers of code within BlueOS. We've got a bunch of development tools built into BlueOS as well to make that easy, regardless of what technologies you're familiar with. And then you can use that to make custom extensions, which can then go on our store and become standard extensions that anybody could download. And the idea here is that just like you have an app store on your phone, we're making a marine robotics app store. If you want to support that dissolved oxygen sensor rather than having to figure that out yourself, you go and there's hopefully an app to support it. You just click that and it's like immediately supported, connected up to everything. And some other developer might have made that. It might be free, they might be selling it. Just lots of options there, just like on your phone. All right, so some of those built-in things, we've got a web interface. We've got camera stream set up. We've got serial bridges, so you can talk to a serial device as if it's connected to your computer, even if it's connected to the ROV. We've got the autopilot connection and configuration, all just standard stuff. We'll probably keep adding to this slowly, but it's still the core things that we need. And then the extensions give you extra features. So I'm going to point out a couple cool ones. This first one is called Zero Tier. Is anybody familiar with Zero Tier? It's super cool. Zero Tier is a service that like basically forms a VPN between a small computer like this and your own computer. So I have Zero Tier set up on here. I have it configured to be on a network. It's all free. And when this is sitting, this Raspberry Pi is normally sitting on my desk at work, but I can access it from anywhere in the world. No problem, it takes like 2 minutes to set up. We've actually piloted an ROV remotely with like 2 minutes of extra setup and free VPN connection. Super cool. We have Cockpit, which is a browser-based control interface. This is one of the things that we're putting the most time into. I want to show you what fast. I don't have a camera here, but this is our cockpit control interface. So you can imagine if you had a camera, it'd be streaming in the middle there. But you've got all the normal instruments, you've got readouts at the bottom, you've got options. And then this is also built to be super configurable. This one's still very much in development, but if I wanted to like add another compass to the display for some weird reason, or add another video player and be streaming a separate video, I can do that very quickly. So I can create a very customized interface. There's some other softwares that let you do this for ROVs because pretty much everybody needs to customize their interface, but they cost like thousands of dollars per license to give you that capability. I'm not going to go into detail on that, but if anybody's interested in Cockpit, we can I can share more about that later. All right, and then device drivers and integrations. This one's really important. So like we have some extensions to support DVLs for position holding and navigation on the ROV right now, like that Waterlink DVL that I showed you on the bottom there. Just has an extension that supports it, talks to the device, sends the information to the autopilot, it's immediately supported. You can imagine that with that dissolved oxygen sensor or some custom sensor you made or whatever you want. You can create an extension that supports it and then repeatedly deploy it out to lots of vehicles. We have a USB over IP extension, so you can, like, I could plug a device into the USB port on that computer and then access it as if it was plugged into my computer here. And we have a ROS extension actually that lets you, that like starts up your ROS instance and allows you to communicate with it as well if you are using that. Let's see, some more here. These are all development tools built as extensions. So they're extensions themselves, but they're development tools. One is called Node-RED, which is a graphical programming language. So you can like drag and drop blocks and create a application program. That's probably like Riley probably designed the makerspace.
I haven't yet,
Haven't
but
used it yet, right?
yeah, me too.
Yeah, it's pretty cool. We're hoping that like May teams will use that because it gives them a very friendly way to start interacting with things in a graphical manner. So like this web interface here was actually created with no code in Node-RED. It's just some blocks dragged together and it's outputting like temperature, ADC measurements, gyroscope measurements. So you could create an interface for a sensor without actually needing to know how to code with that. But the diagrams end up looking like this. We have one called Jupyter, which is a Python IDE that lets you program in Python and run the code right there. So basically, like you're programming directly on your vehicle and can click play and run the code right there. You can install libraries and dependencies, and then we have VS Code, which can be used for any language. All just developer tools to help people build in extensions. So let me talk about this last slide, and then I'll just show you some of those in real life. So you can imagine you can use these extensions for device integrations, custom behaviors, custom widgets in our cockpit application, and then share those with your colleagues, your friends, somebody across the globe who's doing the same thing. And rather than sharing a GitHub repository, you can share an extension that they can download with one click and just have it working. So to build an extension, just a couple files are required. There are no there's no specific programming tools you have to use. You can use whatever you're comfortable with, as long as it ends up hosting a web API and interface. So we don't have to go into details, but if you like Python, you can use Python. If you like something else, you can use something else. Yeah.
As far as doing the programming and things like that, do you have a pretty extensive documentation set right now, or is that?
We have pretty good documentation. We're getting making it better.
Sure.
But yes. So let's take a peek at that. Awesome. All right. So when you first come to BlueOS, you'll be greeted with a page like this. And there's, on the left side, there's a thing that says extensions. So I clicked on that. It brought me to the extension store where we have all of the currently supported extensions. So like, let's see, there's one for the Waterlink DVL here. Nortec wrote an extension for their DVL. We've got a sonar viewer here for cerulean sonars. Sonars, like people are starting to use this, which is pretty cool, but it's still very, very early. And then I can install one of these very easily as well. So let me try to do that. Hopefully nothing will break. So I'm going to try to install this USB IP extension here. So I can check out the versions that are available. Click install. Cross my fingers. Hope the demo works. And so it's going to download the Docker image for that. That's the containerized code and the libraries and dependencies that it needs. Get it installed, and it's just going to start running that code. So you can imagine that would be the process for anything you're going to install. If it's your own code or somebody else's. Give it a second.
Are you running this on a platform?
I'm running on a Pi, there's a Pi 4, yeah.
Yeah.
But so right now we only support the Raspberry Pi, but the goal is to eventually support any computer. So you could, like, if you want to put it on a Jetson, you could put it on Jetson, have much more computing power. If you want to run it locally on your MacBook, you can do that as well. That's the idea. There, so that extension's installed, hopefully running. I don't actually know what that one looks like when it's running, so wasn't a great example. But you see the basic idea there. So let me show you a couple of those. Cockpit was one of the extensions. This is the Node-RED extension. So this one was already installed on my computer. I just clicked Node-RED on the left side, and it opens up a tab where I could create a Node-RED flow to connect to the sensor to an interface or whatever I want to do. Let's see. Here's the USB IP one. Never installed this one, so I don't know what it does, but it's at least got a little web interface here. Doesn't look like anything's loading. Let's see if there's any other comments to install. This is a good example. So this is Cerulean's sonar view application, so I'm gonna install that as well. I know that one has a nice user interface to look at when you're done. And then while that's loading, I'm gonna show you the most basic extension code for those of you who are interested. So this is all the files needed for a really simple extension. This one's just a static web page, just says hello world. And it's got an index file that says hello world. It's got a little metadata file that registers as a service so that BlueOS knows about it. And it has a Docker file which configures how that container is built. So it's probably less than 100 lines of code, all available in a template here to get started with something. And then you can get infinitely more complicated from there. Yeah. So let's see if that one loaded. All right. Okay, so sonar views over here on the left side now. I'm gonna click on that and I've opened up. So it's running the interface for Cerulean Sonar View now. I don't have a device connected, but you can see their whole user interface is just built in here. And if I had a device connected, I could connect to it, would instantly have a sonar view for the device. And then if I wasn't happy with that, just uninstall it. It's gone. It's not affecting anything anymore. Don't have to worry about it. All right. Any questions about this?
You mentioned earlier that eventually this extension store is going to be similar to an app store where you might even have paid extensions.
That's the idea. Yeah, we have to figure out if that would actually work.
Well, I mean, would there be any licensing issues if someone were to just build an extension that would circumvent? I guess this is probably very early on, but.
Yeah, I mean, yeah, so you're talking about could somebody build an extension and just load it in without paying for it? Yeah, we'd have to have security built into the extensions and authorize them, of course, but yeah, that is the idea, because if, let's say you have, let's say somebody wants to make an application that guides a ROV pilot on how to do a photogrammetry inspection, and it gives you like, nice little arrows and shows nice graphics of where you need to take pictures to get a really good, photogrammetry model. And so it's like somebody would probably be willing to pay for that. It's gonna save them a lot of time, maybe prevent them from going back out the next day and collecting more data. So if somebody wanted to develop that, they could totally do that and hopefully charge for it, it's valuable to people. Yeah, we'll see. That's still a question. I'm trying to get feedback, so I'm curious what people think, yeah.
So for example, the ROS extension,
Yeah.
it loads up a Docker container and then runs an instance of ROS core. Is there a bridge that makes all the other extensions available? So the ROS interface for a pub subsystem?
Yeah, so let me show you. So there's these available services, and so like I just installed SonarView, and now it says SonarView is an available service here.
Mhm.
And if I click on well, I'll just went straight to it. Let's see, there's no API for that one. Let's show a different example. This service is called Navlink to REST.
Okay.
So this is like a REST API to access all of the information coming from the autopilot. And so these are all the messages that are available. I'm just at a web URL. If I want to know what the orientation of the vehicle is, like your ROS program would be able to look at that REST endpoint and get a live message, so it can talk to any other service
Gotcha.
quite easily. Yeah, any other questions? Yes.
Sorry, I was a little bit late, so you may have covered this already. Is this gonna be a licensed OS, or, I mean, how are you guys, this is.
No, it's
not
free and open source. Fortunately for us, we make our money by selling hardware, so we don't have to sell it as software.
Okay, if I could ask another question, it's maybe a kind of delve into the realm of business development or whatever, but how does that actually work? Because, you know, the money behind it is not the, like, tinkering with it, it's the support and the kind of keeping things current and et cetera, which is a big job and expensive.
For sure, yeah.
Because
So I
we
think
get
it's,
so much money on robots that we can just burn it on creating open source sort of software.
well, we have to make the robots very capable. Like you can think about, like my MacBook here. The reason I like it is mostly because macOS is so good, is so stable, and that's free. Like I get free updates. I don't have to pay for it. I don't have to license it. Happy to pay for the hardware because it has that. So we're hoping that same effect will apply to the vehicle. And you want to use a vehicle with BlueOS because it's a much better experience than anything else.
That's a premium computer, and you sell, your market is selling affordable robotics. That almost seems like, I'm not kind of like.
Sure.
I mean,
Replace Mac with Chrome OS and Chromebooks. The cheapest computers running open source software.
I'm super interested in this, is
I
very
like-
awesome.
I like the questions. And then, I mean, of course, like we realize we have to make money to support it as well. So, so there are two paths we're interested in that. One is selling extensions, like extensions that other people develop, just like an app store and taking some cut of it. Of course, that relies on us having enough users and enough interest for that action. And then the second, I'll talk about in a second, but there's no question.
Me maybe getting to it, but interested in just what the supportability of is for the software.
Yeah, so I guess at the moment it's open source, and it's like our software team is answering questions. We have a Discord community. We have like 50 or 60 active users there. So there's other people supporting as well. So if you're interested in using it for drones, so they're like getting in there and supporting and adding features as well. And I guess the answer is I also haven't thought about it that much. We don't have that many users yet, so right now we have about 600 monthly active users and about 150 a day, 150 vehicles powered up every day. Got normal, sends back just their IP address so they can keep an eye on it. Yeah.
So you were alluding to this earlier, but do you have sort of a rough breakdown of what are your user communities? It sounds all the way from like middle school, certain corporate users, to maybe the government, academia.
Yeah, that was the answer. Pretty much.
Give us an idea of the breakdown.
Just roughly, it's a little hard to tell. It's about 60% of our business goes to businesses as a whole. That includes our distributors. So it's a little hard to tell what their end applications are. And then about 20% goes to like academics of some sort, whether that's ROV competitions or research labs or universities. And our 10% is military, law enforcement, government, maybe
And then, so the outreach side, how deep does it go? I mean, do you end up with like middle school?
Yeah.
Somewhere?
Yeah, I mean, yeah, that's like this thruster here, literally, the T200 right here is like used in middle school, make competitions. And we're also on, the, like, was whole vehicles. Which is pretty cool that one product can serve that whole range. Yes.
I just wanted to ask, what is pirate mode?
It's trying to make it easy to use. So like, you can see there's a ton of stuff on the left here, including like this page that shows you all the API endpoints, which would be scary to some users. So when you're in the default mode here, it just doesn't show you all the scary stuff.
Okay.
Yeah, plus it's fun. All right, I don't know that many more slides, and I love the questions and discussions, so. You can,
What's the limitation on APIs? I mean, it's dependent on the hardware, but with the Raspberry Pi 4,
yeah,
um,
so APIs, you can have as many as you want, depends what they're like doing in the background
Yeah.
to serve their data. So the main limitation would be if you want to do any computer vision or high processing things, Raspberry Pi is not suited for that. You can we've made an extension to look at fiducials and figure out the ROV's position, or do a little bit of machine vision, but it's you're pushing it to the
sure. Hence your comment about getting it on other platforms.
Yeah, exactly. Once people have power, they want more power. All right, then I don't know much about this because it's still a very early idea for us, but I just want to get feedback on this. And so when you registered, one of the questions was like, how do you currently get your data? What do you do with it? How do you store it? And so we're interested in that question. And the reason is that the last part of this, besides the core and extensions part, is that we want to have BlueOS also connected to a cloud service, so that this Raspberry Pi right here, or let's say this ROV here, after I go on the dive, I come home, power it up, and can upload the video files and the data logs to a website. And then you as a user can keep that organized, manage it, share it with your client or a friend, and make use of that videos. I don't know about you, if you've got an ROV, like I would take videos and then they just end up buried deep in my hard drive somewhere until I erase them when my disk is full. It's like hard to actually make use of all the data you're collecting and keep it organized. It's like there's so much. So if people are using this on robotic systems, then inevitably you're going to be using that to collect data, and that data has to go somewhere and be visualized and shared. And so we're just in the early stages of building this, but the idea is that we would have a BlueOS cloud that would handle that as well. And you could look up a dive from a year ago and pull up all the data files, watch the video again. There's also possibilities to monetize that, like potentially people would be willing to pay for storage of their videos if they're viewable really nicely and organized really well. You could send that video off to a post-processing service that does structured promotion and turns it into a 3D model. That would be very valuable. So there's a lot of possibilities there. Super early, so I'm interested in your ideas, Melissa. Any questions on that?
Yeah, actually, I like the cloud idea with, if you have data that can be, just once in a while that is being, being up and then the driver, the user, can actually display that for the scientists to see.
Totally, yeah, it's hard to see it all. All right. Then this is just kind of to summarize some things here. So the core technical features here, it's built on Linux. It's using this containerized core and extension architecture. That part's really important, but you won't notice it in a second. It's built around the latest web technologies, like REST APIs, WebSockets, WebRTC, web user interfaces. That stuff is pretty feature-proof because it's what everybody is building their software on now. It's very flexible. Our part of the code is written mostly in Python and Rust. If you're not familiar with Rust, it's a potential C++ replacement. C++ has been around for so long, but is prone to memory leaks if you're not a really good programmer, so Rust makes that much safer, it's a much more modern language. And we'll eventually support computers other than the Raspberry Pi. Jetson is very high on our list, but just x86 in general, computers are high on our list as well. And then last slide, I've just pointing to some documentation here. So we've got documentation on how to develop your own extension. We've got a Discord channel where you can chat with other users, ask questions, get support help. We've got example extensions, we've got development templates, but we're trying to make this easy. Hopefully we'll make a great product and then it eventually turns into something good for us, even if that's just selling more ROVs because the software's so good. That's an acceptable outcome for us. Yeah, so that's all I've got. Yes. Any other questions? Yeah.
Yeah, there's, we, here at Scripps often, build stuff that, we want to have in the field for a long time, like long duration sampling, like the buoyancy gliders,
Yeah.
profiling vehicles and stuff like that. And so then obviously the hotel load for those systems is a major component of the overall power budget. And so I was interested about your statement about, Raspberry Pi and looking at other computers and other processors. And what I was gonna ask whether you guys, how far down that road you guys have gone and whether you could look at some of these.
Well, we're mostly looking at higher power, not
Okay.
low power.
Okay,
Yeah, I don't think it's a great choice for a glider. Just because your power requirements are crazy.
yeah, but yeah,
But we
everything
can imagine-
else about it is like that I'm seeing up here is really great. Or at least for innovation in that space, you wouldn't necessarily build like a production system that's gonna be the next Argo float. But if you wanted to prototype those kind of things and you wanted to be careful about, have at least some ability to be careful about the power budget, that would be a nice space, I think, for some of the stuff we do around here.
Absolutely. Cool. Thanks for that.
Yeah, what's the experience with running the OS unattended for a long period of time, like days, hours, days, months?
Good, yeah.
Yeah.
This particular one here has been running on my desk for like almost a year, every day, all day. Pull up the video feed when I'm traveling, like there's.
Without a reboot in the over a year? I guess for like-
Not without a reboot at all.
Yeah.
Like I'm updating the software and things, but we're trying to make it able to handle that well. And I should point out, since the software is running in these containers, there's like the underlying Linux that's running is pretty simple. There's not much going on there. It's mostly just keeping the lights on and running the containers. And so it's also monitoring that if it sees that one of them crashes, it can just restart it. If your BlueOS core crashes, and then it will just roll. If it can't restart it, it will automatically roll you back to an older version and try to start that one. So we'll come back in some form. Definitely, it's still early, so I wouldn't say it's like really sure. But we'll be. Yeah.
So with the video feed, now the pipeline has like 2 video inputs. Can you stream 2 video inputs through this as well?
The videos on a Pi are actually outputs. So like we just use a USB camera,
Oh, okay.
so you can connect up a lot. So. So you're welcome to take off. I got 5 minutes. Yeah. Question.
Now for your blue cloud, if you do cloud computing with your data to make decisions for your BlueOS.
Oh, like live closed loop control system from the cloud. Theoretically, yes, there's lots of possibilities. Or you could have a pilot on that end. Since they're all connected, you could have an office building full of ROV pilots. They're flying ROVs around the world connected to the internet. You could potentially be doing some data processing on the cloud and then sending. It's all possible. Yeah, that sounds cool. And there's a lot of post-processing opportunities as well, just from having all that data there. On my slide. show that. On the cloud part here, the goal here would also be for all that data to also be accessible through an API. So with the user's permission, you could like send that data to a third-party service to process it into a photogrammetry model or do computer vision to identify the species that are in the video or whatever that happens to. All right, so that's it. If you want to stick around, ask any questions, check out any of the hardware, you're welcome to do so. You can open up the boat and check out the pieces in there. Otherwise, just want to say thank you all for coming. Hope it was worth your hour.
Yeah, thanks. Thank you.